There are a few more properties of exponents that I want to make sure we understand. One of them is how to simplify fractions that contain variables and exponents in them. So, a rational expression is said to be simplified when the numerator and denominator have no factors in common. So we're looking for pieces that can cancel from both the numerator and the denominator. So first you need to view it as factored, which means written as multiplication in the top and the bottom of the fraction, and then look for factors that are common and remove any factor equal to 1, meaning if it matches in the top and the bottom. So let's just do some examples and see how this fits into what we already know. So for the first example, I have 28a over 12a. So we want to look for factors. First, I'm just going to focus on the numbers, right? Let's just ignore that the a's are there. How would I simplify 28 divided by 12 as a fraction? And I would look for what's in common between 28 and 12. And in this case, I think they both have a factor of 4. So I'm going to write these out as 7 times 4 for 28 and 3 times 4 for 12. So I still have 28a over 12a, but now it's just 28 is 7 times 4 and 12 is 3 times 4. And I picked this factorization because I wanted to specifically get these 4's to match. Because once they match, they equal 1. 4 divided by 4 is 1, and multiplying by 1 doesn't do anything to this fraction. So it's just cancels in that fraction. Same with a divided by a. I don't know what the value of a is. A could be any number except 0, since it's in the bottom of a fraction. But a number divided by itself is always 1, so these will cancel. Now, before we're reducing fractions, I just want to connect with what you've already done. Like we might have just said divide by 4, divide by 4. That does the same thing as canceling those 4's. So I just want to make sure that's clear, that especially for the number part, if that feels more comfortable for you to get that 7 over 3, that's totally fine. As long as we also see that the a's cancel in here, or reduce. So our final answer is just 7/3. All right, let's try the next one. So 3 and 5 don't have anything in common. That's not going to do anything. But these x's are in common. Since there's both an x in the top and the bottom, those cancel. So it just reduces to 3/5. That was an easy one. All right, let's try one with a squared. So a squared divided by a squared. Since they're both squared, they cancel. If one were to a different exponent than to the other, we'd have to do something different, and we'll do examples like that next. But if they're both squared, then they cancel. And then we just have to worry about the 8 divided by 4. 8 divided by 4 is 2, or we can think of it as, let me write it out as a different way in case it makes more sense. If it doesn't make more sense, then if you can get the same answer a different way, that works too. So I'm writing 8 as 2 by 4, 2 times 4, so that way the 4's cancel. And a squared, another way to think of it is a times a. So all the 2 a's on the top cancel with the 2 a's on the bottom. And what we end up with is just 8 divided by 4, which is 2. So there's a couple different ways you can think about how to get that 2. All right, let's keep going and see how these go. So if you like this option of writing it all out, that will certainly work in this next one. So instead of x squared, I can view it as x times x. And 36, remember I'm trying to cancel the 9 or reduce the 9. So I'm going to view 36 as 4 times 9. Because that way I can look and see, oh, well, these 2 9's, those cancel. One of the x's cancels from the top with the bottom, but there's going to be one x that's left in the top, and the 4 is left in the bottom. So our final answer is x divided by 4. Another way to look at this, remember, is just reduce the numbers first. So 9 divided by 36 would be 1/4, because 9 goes into 36 4 times. And then x squared divided by x, there's one x left in the top. So another way to look at it is to subtract the exponents. Let's maybe do that with this one. So this is written as more of a fraction multiplication. And so one thing we learned when we were multiplying fractions last term in Math 60 is to cross cancel. So I'm going to cross cancel in this problem, which means that I'm going to look along the diagonals and see what's in common. The only difference is in Math 65, now we have variables in the fractions, but it's the same idea. So with 5 and 10, what I'm seeing is that they both have a 5 in common. So I'm going to divide by 5, divide by 5. And in the other diagonal, I see they both have a 6, so the 6's can cancel. But then a to the fourth divided by a, let's maybe write that out. I need a little more detail. So right now I have a to the fourth over 2a. What's going to happen is that one of the a's is going to cancel, but there's going to be 3 left. So we're going to subtract the exponents. So when we're doing variables to an exponent, we're going to subtract the exponents. And the leftovers stay on the side with the larger exponent. Leftovers stay on the side of the larger exponent. All right, so when we cancel one of these a's, the leftovers stay up here with the 4. So it ends up being a cubed over 2. Because 4 minus 1 is 3 a's that are left on the top. And the over 2 stays there because 5 over 10 is 1/2, so it's 2 on the bottom. Again, because the larger number is on the bottom, so the 2 stays with that. All right, let's try another one. So this one's all one fraction, so we're going to view it as the numbers and then the variables separately. So let's just do the number part. 14 out of 21. We want to look for what goes into both 14 and 21. It's 7. So I'm going to divide both the top and the bottom by 7, just like we would with any fraction with numbers on there. So 14 divided by 7 is 2, and 21 divided by 7 is 3. And those stay on their respective sides. All right, next one, w squared over w to the fourth. We're going to subtract the exponents. 4 minus 2 is 2. But the leftovers go on the side with the larger exponent. So the w squared, the leftover 2 from when we cancel, goes on the side where there was 4 to begin with. So we've taken away 2 w's from the top and 2 w's from the bottom. That's the same thing as dividing top and bottom by w squared. That's really what we're doing, is dividing by w squared when we say we're taking away 2w. All right, next thing I see is x and x. Notice both these x's don't have exponents. The 6th power is just on y, and the cubed is just on y. That's why it's so important that we understand order of operations, so that we know that this exponent goes before multiplying by x. So x to the first and x to the first, those just cancel. They're done. So now we deal with the y's. We have y to the 6th and y cubed. So there's going to be 3 left over, and the leftover go on the side with the larger exponent. So it's going to be y cubed in the top. I made my fraction way too long on that one. And I don't know, I was not feeling the divided by w squared. If you liked that, if that made sense to you, you can keep it on there. If that was confusing, it certainly doesn't need to be there. All right, hopefully this is starting to make some sense. Let's keep going. So again, when it's written as multiplication, you can view it as cross-canceling, or you can just put these together right now and do it like we just did, if that makes more sense. I sort of like cross-canceling. You can, if you took Math 60 with me, you probably know that. So let's do it. We got the 2 diagonals. Let's do this one. Those numbers are smaller. So 3y and y squared, what they both have in common is a y. So I'm going to cancel one y from both top and bottom. So that means, I'm going to rewrite this. On the top of this fraction, there's just going to be a 3 left. On the bottom of this, there's just one y to the first. Because we had y squared and y to the first, so there's one left over y, and it goes on the side with the larger exponent. In the other diagonal, 16 and 4 both have a 4. So if I divide by 4, we get a 4 on the top of this fraction and a 1 on the bottom of that one. In other words, 16 divided by 4 is 4 over 1. And now I have an x squared over x. So one x is going to be left over, and it's going to be on the side with the larger exponent. So this x is going to cancel, and what's left on the bottom over here is just a z. Now, if I put these all together, I get 12x over yz. Because multiplying by 1 doesn't do anything, and exponent of 1 doesn't do anything. So our final answer is 12x divided by yz. All right, I saved the most complicated for last, but I think we can do it. Let's try it. All right, yeah, so now we gotta pick where to start. I usually go with cross-canceling, so let's keep going with that idea. That if it's written like a multiplication like this, I may as well just do the diagonals as two separate pieces. So this diagonal, I see a 3 and a 6, so I can divide by 3. So instead of 3 over 6, I have 1 over 2. X squared over x, so one of the x's will cancel, and the leftover x stays on the top because that had the larger exponent. And so there isn't an x on the bottom anymore. That's canceled. Same with the y. Y squared divided by y is just one y left on the top. All right, let's try the other diagonal. 15 divided by 5. So if I divide 15 by 5, I get 3. If I divide 5 by 5, I get 1. Now w divided by w cubed. So again, we're subtracting when we divide exponents. So it's w cubed minus a w. So it's w squared on the bottom, and it's on the denominator because that's the side with the larger exponent. Z cubed divided by z, there's going to be 2 leftover z's, and it goes on the side with the larger exponent for z. So now we put this all together. 3 z squared times x times y over 2w squared. At the end, you should also do a double check to make sure there's no numbers or other common factors, none of the variables match up, so this is considered simplified. That was as crazy as it gets. Hopefully we follow along okay with that, with just subtracting the exponents. Let's do 2 more properties of exponents, and then there's a lot of practice to do to make sure we have all these sort of straight in our heads. But let's try some distributive properties. Hopefully remember the distributive property from Math 60. So one way we distribute, in the more traditional way, is that multiplication and division distribute over addition and subtraction. So multiplication and division distribute over addition, subtraction. And so this is an example of that. So we have multiplication on the outside of the parentheses. So we distribute it, meaning move it inside the parentheses, 1 to each of those terms. So now let's try it. So that would be 4x times x squared plus 4x times 3x plus 4x times negative 4, or you could have made this a minus sign. Subtracting is the same as a negative, adding a negative. But now we need to simplify. And this is where our rules of exponents come in. If I have x to the first and x squared together, that makes x cubed. So this would be 4x cubed plus 4 times 3 is 12. And then I have x times x, that makes x squared. And then now I am going to remember to make that a minus sign instead of the plus I wrote here. So it's minus 16, and then there's an x in there as well. So simplified, this would be 4x cubed plus 12x squared minus 16x. So that's our traditional way of distributing multiplication or division over addition and subtraction. But it turns out that exponents distribute over multiplication and division. So let's write that. Exponents distribute over multiplication and division, but not addition subtraction.